Hello, and welcome to The Confident Commit, the podcast for anyone who wants to join the conversation on delivering software better and faster.
If you're looking to build a trusted ship, tune in, let's confidently commit.
Today you're listening to episode 6, and we're joined by the brilliant Chris Richardson to talk about the importance of architecture in all of this. I'm your host, Rob Zuber, CTO of CircleCI, industry leader for all things CI and CD. Hey, Chris, thanks for joining me today.
Oh, it's good to be here. Hopefully I've had enough coffee today to be brilliant, but I'm not sure.
Well, great news for someone like you, I think, is that your voluminous knowledge base and track record that precedes this particular conversation will fill in any gaps for people. I don't think you have to be brilliant in every moment to be considered brilliant.
At least I'll try and be humorous.
All right, sounds good. Sounds good. My coffee level is also in question, but we'll make it work. Cool. Well, it's great to have a chance to chat with you. And as I alluded to, I mean, I think that you're someone who's done a ton of thinking recently and over time about architecture. And I feel like architecture is in kind of we've seen a lot of change as we have across all of software delivery and software development. I want to say over the last 20 years, but I always talk about 20 years because that's kind of the span of my career more than because that's the specific window in which all these changes have happened. But certainly around, agile and rapid delivery and breaking things down and stuff like that. And I think architecture has followed suit in some ways. So just to kick things off, I mean, what does the word architecture mean to you? When you talk about architecture, what is it that you're specifically thinking about?
Yeah. I mean, I think sort of in an informal way, I mean, architecture is all those sort of big picture decisions that you make about the overall structure of your application or system, right? I mean, there is sort of there is a more formal definition of it, which I pulled up just so that I could quote it correctly. But it's like the software architecture of a computing system is the set of structures needed to reason about the system, which comprise the software elements, whatever they are, the relations amongst them, and the properties of both. So you've got a set of these elements that have relationships between them. And it's a tool to enable you to reason about your application, in which you could just sort of distill that down into, it's like a bunch of boxes and lines. Right.
Yeah.
That's what sort of architects are famous for drawing. But then if you think, well, what are the nature? And sort of one of the interesting aspects of architecture is that, if you think about, we go back into the real world, because you could say that's where the term has its origins, right? Kind of interesting. I've never really thought about the origin of the term. But, imagine that you have a building that's under construction. I mean, that has an architecture, and depending on who you are, which stakeholder in that building, you have quite a different view of what architecture is, right? So if you're a structural engineer and you're concerned with, I don't know, steel and concrete, if it was a high rise, right? Mm-hmm. Whereas if you're an electrical engineer, you're concerned with all sort of wires and stuff, right? Where in the plumber, it's like tubes and pipes, that kind of thing. Mm-hmm. So, so it's actually, architecture is actually multidimensional, and software is the same. And, you're talking about 20 years and trying to remember when this was defined. There was a 4+1 model, view model of architecture, a software architecture that sort of took the same approach and said there's different perspectives. So as a developer, we build object-oriented software. So architecturally, we're kind of concerned with packages and classes. But then another perspective on that is how those classes get compiled into modules, jar files, say, if you're in the Java world. And then how those modules are combined into components or executable or deployable things, right? Which could be literally executable files or, say, Java war files. And then there's the process view, like bunch of communicating processes. And then there's the deployment view, which is like nodes and networks, right? So if you're an infrastructure network engineer, that's what you think of, right? As opposed to me, a Java developer, I think of classes. And then the plus one are the scenarios that animate all of this, right? That show how requests flow through the system. And you could view it from a class perspective or from a network perspective, and everything in between.
Right. So it's really interesting that I mean, that's an important overlay, that the kind of stakeholders and who's participating and how they're viewing what's effectively the same architecture, but what's important to different stakeholders. One of the things that I think is really interesting, I mean, you sort of said elements, whatever they are, is that's something that's shifted a lot. And, you've done writing, speaking about microservices as an architecture. One of the things that I've been thinking about a lot lately, many people have moved to microservices based architectures. Many teams have, you build it, you run it sort of models where engineers are on the pager for the pieces they've put into production. It kind of feels like we've turned every engineer into all of those stakeholders in some way. Do you like, as a member of a software team, now I need to understand the network and the operational, capacity and the deployment tooling and everything, which is ostensibly great, but also drastically increases the cognitive load, the amount of work that any one engineer needs to be able to understand about the system. Does that resonate with what you've seen? And do we have pathways to get ourselves back out of that, do you think?
Yeah, no, that's an interesting observation. And I think partly I agree with you. I think, partly I disagree with you in the sense that, like, some organizations, it's still sort of quite siloed, right? I mean, but you could say that we have this trend towards DevOps, should we say, right? Which kind of embraces an engineer does everything. And in general, that's good, right? I mean, like, if you're responsible for something running in production, that's really encouraging you very strongly to write production-ready code. Right? Even is as simple as, like, putting in the right log statement so that if there is a problem in production, you can actually troubleshoot it, right?
Yep.
And yeah, so I feel like there is this sort of growing cognitive kind of complexity that we all face. But then at the same time, I think another way of sort of thinking about sort of the whole DevOps thing, right, is, and this is in the book Team Topologies, that's one of my favorites, right? It's all about, like, people like the operational people. They provide a platform that abstracts away a lot of this stuff so that I, as a developer, can focus on writing my service. And then I have a sort of kind of self-service deployment platform that I use to deploy things, and all the low-level networking and whatever stuff is sort of hidden from me because I don't need to be aware of it. And I want to focus on understanding the business problem that I want to solve.
Yeah, so agreed, both on that being a great book and the model that it provides in terms of effectively platform teams, pulling away some of those layers, creating shared capabilities. I sort of get the sense, and it's also important that you called out probably the bubble that I live in, which is, my customers are all practitioners of CI and CD and operating in a very, we'll call it DevOps way, but this services based, you build it, you run it. That's probably not the whole world. So we have to remember that. But I do think that layer is really good, and that notion of abstracting away those pieces. I wonder how good we are at it and how many people have gotten there. It feels like we're in that transition, do you know what I mean? Where we've taken on the complexity, but we haven't solved the complexity in this new kind of pattern. Does that make sense?
Yeah. Well, yeah, this is a quote that comes to mind repeatedly. It was William Gibson, right? It's like, the future is already here. It's just sort of unevenly distributed. I think that's the right quote, right? And So yeah, so you look around, you do a survey. Clearly, some people will be doing, quote, the state of the art, whereas other people are lagging somewhat, right? I mean, you could even take this, like you think about microservices, right? So it's kind of funny. Like I think the blog post that promoted the term was back in 2014, which is, well, I guess a long time ago. But then it was all new, it seemed new and exciting. But then in reality, companies like Amazon had already embraced that way of working back in, like, I think it was 2002.
Mm-hmm.
So there's all constantly, you find there's these ideas that you thought were new, but someone somewhere has been doing it that way for a while, and it takes a while for things to diffuse and become sort of mainstream.
Yeah, I think that's probably a very important point, and like the sort of diffusion or adoption of these things. And second, one thing that always occurs to me in this, you cite Amazon as an example, is we tend to get the blog post or the tiny little window into what's happening inside of an organization like that and say, okay, this is the solution to all of our problems, without understanding everything that goes with it. Do you know what I mean? Like you're talking about team topologies, for example. How are teams structured in order to support the choice of services as an architecture? Without diving in and understanding all of it, I think you run the risk of adopting one piece that you don't necessarily understand or understand the implications of. And on that point, I mean, you mentioned team structure, you mentioned platforms. Architecture and organizational structure have been correlated for a long time, thanks to Conway. I think you can't go to a conference without someone quoting that. So as you work with organizations on architecture, do you spend a lot of time also working with them on how to structure and organize themselves in order to support the kinds of changes they're looking to make?
I think partially. I mean, like in the sense that, so one thing I constantly talk to clients about is there is this concept of a success triangle, which is where in order to deliver software rapidly, frequently, reliably, and sustainably, you need three things. And one thing is process, which is DevOps. The second aspect is organization, right? And that's a network of loosely coupled, autonomous, cross-functional product teams, right? Mm-hmm. And then the third part is you need an architecture to enable those two other things. So I sort of in many ways I present, say, microservices as the enabling architecture to achieve the goal of loosely coupled DevOps teams, right? So, and I focus on the architecture piece, but at the same time, I make it, very clear that you have to master DevOps and you have to have this loosely coupled network, because if you don't have those other two pieces, you're not going to properly realize the benefits of the microservice architecture.
Got it. That makes a ton of sense. So you're having the conversation about the implications, but maybe not sitting down and saying, so therefore I think this person should go over here and this person should go over here. I mean, that's up to an organization to understand.
Yeah, but it's I sort of, I mean, we can touch on that, but it's sort of, that those are adjacent areas to sort of what I focus on.
Right. And so I've been wanting to ask this question, and it seems so simple, but how do you know when your architecture is good? I mean, what are signs to you or to any of us as we're working on something that we need some change, or that we don't? That, I think we always feel like everything could be better, but when would you say, yeah, this is in a good state, and you can tell for the following reasons?
Yeah, well, that sort of gets into the issue of like, what's the point of this architecture thing, right? As what is there more to it than just being able to call yourself an architect, which sounds awfully fancy, right? So the way I explain it is like, if you look at the requirements for an application, there's the functional requirements, right? The user stories. And then there are the non-functional requirements or ilities or software quality attributes. And essentially, the architecture enables you to achieve a given set of non-functional requirements, like scalability, availability, I don't know, extensibility. It's funny, there's a Wikipedia page that lists a whole lot of ilities, right? And then there's some other ones that don't quite fit into the ility framework.
Yeah.
But sort of and it's interesting, right? Because I came at it from the perspective of, I'm interested in this microservice architecture thing, right? And it was like, well, what is it? What do you mean by what do you mean by architecture, and what do you mean by microservice architecture? And I think this was like back in 2016 or 2017. I think I started looking into kind of what those words meant, which then led me to rediscover a whole bunch of classic architecture work from like SEI, CMU SEI that was done in the 90s and so on. And then that kind of goes back into, architecture is to enable you to achieve certain non-functional requirements. And in particular, the area where sort of the primary objective around the microservice architecture is all about having the right it's a way to enable you to deliver software rapidly, frequently, and reliably and sustainable over the long run. And the reason you need to do that is that sort of the world is super dynamic and unpredictable. Gosh, even epidemics come out of nowhere, right? Which is usually disruptive to IT, right?
Yep.
And so, businesses need to be nimble, which means that, and given that software is powering many products and services offered by business, IT needs to be nimble and agile and deliver software rapidly, frequently, and reliably. And there's sort of been a whole bunch of work around that, right? Well, actually, if you just deconstruct the success triangle, DevOps is all about delivering a stream of changes frequently into production. And in order to do that, you need an architecture that's highly deployable and highly testable. So deployability and testability, if you want to fit things into the ility framework. And then in order to have a loosely coupled organization, you need to have a loosely coupled architecture, right? That's Conway's law. Sort of architecture and organization are like, what's the word? Isomorphic. I know there's some fancy word for that. And that actually goes back to needing an architecture that's loosely coupled and modular. So you sort of have these architectural requirements that you need to satisfy. And then interestingly, you can actually quantify how good you are at delivering software rapidly, frequently, reliably, which is sort of like you're going back to your original question about how do you know how good your architecture is, right? So you can quantify the sort of development velocity related aspect of it with those DevOps metrics like lead time, right? What's the time from a developer committing a change into production and having that doing a git push, and then that change being deployed into production, right? And like good number there is 15 minutes. And that actually that's a requirement that impacts your architecture and also impacts, how your whole development process as well, right? And then another metric is deployment frequency, which also goes back to sort of architectural and organization and process requirements, right? And then also there are some metrics around how reliably you're doing it, right? Like what's your change failure rate, and then your mean time to recover from any production outage. So you can measure those metrics, and in particular, if you start to see a decrease in those metrics, then that's say a hint that, if you've got a monolith, maybe you're outgrowing your monolith, assuming that you've optimized your development process, right? You can, at some point, you're likely to hit a wall where, and this is very specific to the monolith versus microservices argument, right? But you just figure out, well, this monolith has got so big that we can no longer deliver changes rapidly, frequently, and reliably, and we need to functionally decompose into a set of services.
Got it. Well, I will say that at CircleCI, we're big fans of rapid delivery. It's the thing we spend all of our time thinking about. And it's absolutely an interesting way to bring those together, and the enablement of it. One thing that I was thinking about as you were talking and you sort of shifted into the more temporal, like moving quickly element, is some of those classic ilities, right? The stability of the system we thought we were getting by reducing the rate of change, right? Like that was the classic model. Well, let's only make changes that are really well controlled and understood and all those things, because then we reduce the risk, which of course proved to be, well, in my mind, proved to be incorrect. And I think that's where we've trended. But how do you pay attention to those things over time, or ensure that you're designing, I guess, for that? Like, how do you design for stability with a rapid rate of change, or quality with a rapid rate of change? How does the architecture play into that?
Well, I think one is, I think you primarily need to have sort of like these metrics, like you actually actively measure and track lead time, like, well, lead time, deployment frequency, change failure rate, and so on. And those need to be elevated to sort of first-class requirements, right? And along with, say, sort of the whole scalability thing, right? I mean, that most organizations deal with sort of scalability, right? Because that's a very customer-facing feature, right? Or metric. But I feel like where a lot of organizations fall flat is there are all these sort of non-functional requirements that are hidden from the customer, which then, and you know, this all gets into the area of like technical debt, right? So you got product managers, let's say product owners, and their focus is on delivering revenue generating features and sort of which is really functional requirements. And I think and apart from like scalability and performance related metrics, there's a whole class of non-functional requirements that are invisible to the end user, and they get neglected. And so your architecture, so not enough effort is actually spent on architecture. I feel like a lot of the time, what architects do is work on big features, big functional requirements, and not spend enough time thinking about non-functional, the invisible non-functional requirements, which are important for long-term sort of sustainable and successful development.
Right. Well, you threw in long-term at the end there. I was going to say every invisible requirement becomes visible to the customer at some point. It's just a matter of time. Like when when your system collapses because it never was going to be able to reach that scale, right? Like it wasn't ready for that. Or when you slow down development enough that you just stop delivering new features because no one understands the code base. I mean, it always ends up in the customer's perception. They just might not understand what that perception is versus, a feature or the site is up or the site is down sort of thing. And I think that's an area where I would agree, a lot of organizations struggle to have that long-term view because it's different. I mean, every system is kind of new in a sense, right? Like that next level or that future is new to everybody. So I was actually thinking it would be interesting for someone like yourself, just to give you work. That's why I invited you here, to show some sort of stories or case studies of this was a decision made at this point in time, and here's where it became a problem sort of thing. Like, I don't think any of us have that time horizon view. And I think it would be really interesting to look at.
Well, it is. Well, I feel like maybe the metaphor is, I mean, organizations, I think typically dig themselves into holes, right? And that every day you dig that hole a little deeper, right? But it probably takes years, right, before you've dug a hole that's deep enough that you realize you can't see out of it.
Yeah, one of the questions that was on my mind this morning, and this feels like a good time to talk about it, is are rewrites just inevitable? I mean, or re-architectures? I mean, it's a bit of both, right? This particular system needs to be rewritten, or this whole thing needs to shift and change fundamentally. Are we just either that? I don't want to say bad. I don't want to be so judgy, but do we have that much of a challenge seeing the future? Or do things change so much in unpredictable ways that we can't tell? And or do we just underinvest? And if it's the other way, if we can't predict, should we design systems that we can easily, rewrite, throw away, re-architect? Is that, sort of acknowledging that there are particular stages of growth that we might not get through?
Well, I think it is possible that, at some point you might have to just throw it away. But the problem you have is sort of like, what do you mean by a rewrite? And I think what's really problematic is if you have to have a big bang rewrite where we have to spend the next 3 years rewriting the application from scratch in order to first recreate the features that we have today, and then add the new features that you actually needed yesterday, right? So you certainly, the way to do rewrites is with an incremental migration or incremental rewrite. And there's the strangler application, right, or strangler fig application, where little by little you migrate functionality from an old application into a newly constructed application. And so, I mean, I think in a way, I mean, one of the appealing aspects of the microservice architecture for me is that, a lot of the sort of the rewrites around, if you have a microservice architecture, then, you can basically rewrite an entire service. Right. I mean, it should be feasible to do that. You could switch its technology stack. Right. You suddenly decide, we've been using Java and we love Golang now. Right. You can rewrite your services from Java to Golang incrementally. Right. Whereas if you've got a monolith, that's far harder to do. And fingers crossed, I kind of feel like if we got it right, we can actually build applications that will survive for a long time and can be incrementally modernized, so we don't end up with these 30-year-old bloated, incomprehensible monoliths, right? For instance, I remember working with a client. I mean, I think they were like a multi-billion-dollar business, and their key business application was like written in some, it was 4GL, if anyone can remember what one of those were, right? Using a database from a company that no longer exists, right?
Yep.
And so a huge problem with actually even rewriting it, because the people with the technology skills, maybe they're retired by now, right?
Right. Yeah, absolutely. And I think that I was going to highlight the people in that, and then the understanding even of what it does, or to your point, the ability to do an incremental change. Like, we'll just take out this piece, but if we take out that piece, does everything collapse? Like, nobody really knows anymore. Those sorts of things. Do you have patterns for I mean, I don't think that particular case is the norm, but there's plenty like it, right? With these systems that nobody fully understands. Do you have patterns for modeling your way out of that?
Yeah. Well, I mean, there are refactoring patterns for, refactoring from a monolith to a microservice architecture. mean, the challenge that you have is that it's like taking a module at a time and turning it into a service. But the problem you have is that module might not be clearly defined inside the monolith and tightly coupled either just through explicit code dependencies, or it might be embedded inside a transaction that then if you extracted it out, has to span the monolith and this new service, which creates a whole host of problems. And so you've got all these different types of coupling that can be difficult to break. I mean, an interesting idea, it's funny, I used it in presentations, it was probably like 8 years ago, and it sort of got dropped at some point. There was this interesting metaphor with the human body, right? So, human body is comprised of a gazillion cells. And cells have a finite lifetime, and, which might be measured in, I don't know if it's as short as hours, but days, weeks, months, years, right? Maybe your brain cells live for a while, depends on a lot, might be long lived. But so if you think about the human body, it is constantly renewing itself, right? Cells die, get replaced by new ones. And so in some senses, you are not physically the same person you were a year ago, right? Bits of you have been replaced. And that's a great metaphor. And this is from Richard Gabriel, computer scientist. He wrote something a few years ago that kind of inspired this. About, that should be a long-lived system so that you can replace parts of it incrementally, but the system still remains the system. And I think another common metaphor around that was like, you got a boat that's comprised of wood and you replace it one plank at a time, but it's still the same boat, right?
Right. Yeah. I was trying to remember the context in which I've heard that, but I've definitely heard it. I think it's a really interesting model. I mean, what is the external interface of your system effectively, right? What is the customer seeing, the user, whoever that might be? You might have multiple users. And then how much of that, is there value, I guess, is the more important point. I mean, I'm no biologist, but there are reasons that your body is replacing cells over time, right? So are there good reasons to be thinking about, this stuff decays, like to the point of the inevitable rewrite, an inevitable rewrite of a tiny little piece of the system that says, you know what, this is good enough for now, but then we're going to replace it with something better when we reach this point, feels very comfortable, especially if it's intentional, right? Oh, this will get us to the place we need to get to. And if that breaks, we know what to do next, but that's a bigger investment. It's not worth it right now. I think we're not always good at that kind of thinking, but if you can do it in those small pieces, could be a great way to actually, mentally model the evolution of your system.
Well, I mean, I think one very tangible kind of driver behind replacement is technology changes. So, technologies come and go, right? And even within a particular technology, the versions come and go, and so there's sort of two types of evolution. And so you look back far enough, right? I mean, it just so happens that like Java has been around for 25 years, right? And which is quite successful. But say within Java, there's been many versions of it, right? And there's a whole notion of with any technology or technology version, you should remain current, right? So, one way of putting that, the relevance of a given technology inside your organization should basically mirror the relevance of that technology in the marketplace, right? So, and I mean, because that has implications for hiring and on all kinds of things, right? And then more tangibly, you want to be able to apply security patches
Right. Absolutely. I mean, the whole notion that you want to be able to keep stuff current, I think is really, really valid. The technology one is particularly interesting to me because I see people adopting technology because it's cool and new versus because it supports some driver for a particular problem you're trying to solve, which might, could be technical. It could be, to your point, business in terms of hiring or maintaining a team. Whether you can get a particular type of expertise in a particular technology stack is a really interesting, like if you're trying to hire data scientists today, for example, you probably have a limited subset of stacks that you would choose from for the work that they're going to do versus front-end developers, et cetera, right? And so there are many, many different reasons, but it's also interesting because Java has been around for a very, very long time, huge base of developers, not exciting maybe for a lot of people, but at the same time, totally stable and well understood, right? And so, and I think that one of the things that I find really interesting that is the early stage of a company versus later stages of a company, right? As someone who's mostly been involved in startups and many of our customers are in that world, we want to get something to market really quickly and use a lightweight, simple tool that we know and can iterate on fast versus now we have scaling problems. Like there's a long list of large orgs today that started out on different stacks because that allowed them to move quickly. And now that's not their biggest concern, right? It's scale and reliability and those sorts of things.
Yeah. Well, it's, and also the choices around technology, it's specific, especially around adopting new technologies. There's sort of technical drivers, right? There's logical, rational reasons for choosing a particular technology. But then there's a whole lot of just sociological reasons as well. I don't want to be too negative, but there's like fashion, right? Mm-hmm. And so it's there's a mix of rationality around this decision making and then emotions as well.
Absolutely. And one of the things that, to that point, I don't know if fashion is the point that I was thinking of, but technologies tend to bring entire communities, right? It's not just, oh, I like this particular language or I think this can solve my problem. But so there's the community in terms of the support. We talked about Java having so many years of tooling and developed libraries, et cetera, but also just styles and approaches. And you sort of bring all of that with you when you make a technology choice, to the point of the social element that I don't think I caught on to that as a younger engineer. And I definitely see it today.
Yeah. Well, humans are like emotional social creatures. Mm-hmm. And in connection with people, it plays a role.
Yeah. I think it's easy for us to forget in the world of technology and engineering that so much of what we do is based on the people doing it, and so little is the code in the end, right? It's a reflection of the organization, of the people involved, individuals, what their personal preferences. It all shows up in your code, in your architecture, by the time you're done. One last sort of parting question, I guess, as we talk about all this, we talked about evolution and growing, and a lot about scalability and systems with independent teams, et cetera. So one of the interesting things that I always see is, you've got this 2-person, 3-person project or startup. It could be in a company, in a bigger company, in a small company, it doesn't really matter. And a desire to adopt all the best practices at the beginning to avoid having to do, make big changes later. And it feels like that ends up being very cumbersome, right? We can create a lot of complexity when we don't even know what the thing is that we're building yet, or, whether there's product market fit, however you want to think about that piece. So if you were starting something new, what would you think is most important to focus on in your early build, and what would you defer until later and not worry about as you're trying to just iterate and get something to market?
Yeah. Well, I feel like you should build the simplest thing possible, right? And using the skill, using whatever skills I mean, assuming you're building your own software, right? Whatever technologies that you are personally familiar with for the most part, right? Because certainly I think, but part of it, if you take a step back, it really does depend on the context, right? Like, so some south of market startup, they start off generally small. And at some level, they don't really know what they're doing, right? Mm-hmm. You have to iterate and figure out what problem you are actually solving, right? And
right.
Product market fit, and you pivot, and then eventually you hit upon the right thing that then causes growth, right? So, and you don't have any significant customers, right? And so you're not dealing with problems of scale. You actually haven't written much code, so you're not generally dealing with complexity either, right? Mm-hmm. And so just build the simplest damn thing that you're capable of building in general. But then, there are many other different contexts for that, right? Where, like, imagine that you're building something small, you're building something inside a large enterprise. And for whatever reason, it's going to be big because maybe it's serving the hundreds of thousands of employees inside the enterprise, right? And so or maybe someone's giving you $1 gazillion of VC, and on day one, you're going to have 200 engineers building some software, or maybe the domain is well understood, right?
Yeah.
So there is a giant, it depends around kind of what your initial architecture should be. And I'll give you another example, right? Like, imagine that you were building a medical application where the software development of medical applications is heavily regulated, right? Imagine it's like some cloud-based product that's controlling insulin dosage, right? Just or something like that. You can't do DevOps, normal DevOps practices. You can't do canary deployments in that world, right? Because lives are at stake. But then maybe there's value in like having a distributed architecture from day one, where the medical part of what you're building is heavily regulated, right? And developed slowly using ISO standard, blah, blah, blah. And then the rest of your system is built using sort of DevOps, right? And so it's a giant, it depends.
Well, I'll articulate that it depends the way that I hear it, because I think it's a great roundup, which is effectively understand your context, right? It's probably true for every decision you'll make as an architect, as an engineer, everything else. You can't just take what someone else has done or said is a good practice and apply it to what you're doing. You need to understand the implications for your business, what matters in your business, what you're trying to achieve, and then you can assess those things and decide what's right for you.
Yeah. That which touches on something that's sort of very, one of the few things I actually am a fan on, right? And it's like this concept of a pattern, right? Mm-hmm. And a pattern is sort of this reoccurring solution to a problem that occurs within a particular context, right? Mm-hmm. And so it's like, how do we do X? And the way in which the solution that's applicable actually does depend on the context within which you're trying to solve the problem, right? So you have to know the context in order to pick the right solution. And then not only that is another key part of a pattern are the consequences of the pattern, which are not only its benefits, but it also has the drawbacks as well as the issues or sub-problems that applying that pattern then creates, right? Mm-hmm. So in any given context, there could be multiple solutions, and each one has its own distinct consequences. And so in order to enable you to pick the right solution, you actually have to think about stuff. to go back to your point, right?
I was going to ask you something else. I don't know how to not end on you actually have to think about stuff. I feel like we'll just summarize 45 minutes and you actually have to think about stuff. I said that was my final question, though. And I did actually want to ask one thing. Is there something that you're working on now or that you see coming up that you're really excited about that you want to share?
Oh, can we finish on you have to think about stuff? Yeah. No. I mean, what do I do? I mean, I these days, it's funny, right, with COVID and the past however many months, I used to just travel endlessly and just be working with clients. And so the past 8, whatever, however many months, I've just been working with clients via Zoom, but it's meant that I've not been jet lagged for the first time in about 8 years. And it's given me a lot of time to contemplate stuff. And in particular, one of the kind of things I spend a lot of time thinking about is sort of kind of like a framework for deciding how to choose between the monolithic and microservice architecture, right? Which in my mind are just architectural patterns. Mm-hmm. And each one has consequences. Neither is an anti-pattern, despite what you read on Twitter, right? And then also, if you pick the microservice architecture pattern, how do you take a pile of requirements and turn them into a set of service definitions? So I'm sort of working on sort of, you could say, a methodology for doing that. Which is like the most important decision that you make the problem that you have to solve in the microservice architecture, but it's also the most nebulous.
Right. Right.
And it's all to do with balancing conflicting concerns about, we want to have services that are team sized according to team topologies, yet at the same time, we have to take into account design time coupling. And also, we got to minimize that. We have to minimize runtime coupling. So there's sort of all of these conflicting forces that you have to balance when you design your microservice architecture.
Got it.
But you have to think. That's the key takeaway here.
I love it. I think that's going to be the coda on every statement. It's perfect. You actually have to think about it. Love it. Well, thank you so much, Chris. This was brilliant. It was just as great as I anticipated to have a chance to chat with you. Appreciate you taking the time. And thanks to everybody who's tuning in and listening. If you enjoyed this, feel free to subscribe on any of your standard podcasting services. And if there's something you want us to talk about on the podcast, hit us up on Twitter at CircleCI. Thanks again, Chris, for joining me today.
Oh, thanks. It was fun.